Hello, everyone. Oh, okay, that's on now. We're going to go ahead and get started soon with the Make Your Own AI Recipes session. Step one is I'm going to have everyone go to Aquarium. So if you were in the previous Driverless AI training earlier today, you've probably already done this step, but this will be the hardest step today. So we're going to go to aquarium.h2o.ai and make an account. And once you've made an account, we'll go on to the next step, but all we're going to do right now is go here and make an account.
Thanks, Michelle. Who here has not yet made this account so that we know? So a handful. Perfect. Just raise your hand if you need help, and we can fix any problems. The goal is to make custom recipes today with Driverless AI. And as you know, this is for ultimate freedom for data scientists, which they seem to enjoy, right? Data scientists want to understand every piece of the puzzle, and every time we do Kaggle, we feel like, oh wow, there's another secret sauce somewhere, and we have a bunch of Kaggle grandmasters around here, so they can maybe help later explain their custom recipes that they have contributed, and you will get an understanding for how you make such magic potion, if it's not already in the system.
All right, so website there for everyone. And then once you log in, you should see this page. So we'll give you just a minute or two more, and then we'll do the next step. Don't click anything yet, just we're trying to see this web page. Can I get a TA in the front, please?
Which lab are we going to click on?
Yeah.
I think we're at that point now.
Once you've successfully logged in, what we're going to be doing today is this session, David's Driverless AI 180. You really want to click on this session. If you click on any of the other ones, it will take about 10 minutes to start up. This one, if you click on, it will start up automatically and you will be happier.
And who was in David's earlier session? A lot of people?
So if you were in an earlier session, that's a really good point. If you were earlier today, after you click View Details, you can go ahead and end your lab and start another one. We have enough, and that will give you the full amount of time, since we're past 2 hours at this point. Yes, so these instances will be on for 2 hours, and at the end of 2 hours, it's going to turn off. So anything we do goes completely away. We can always start a new session, which is what we're going to do for those of you who were here earlier today, but we won't have what you built last time. Tomorrow, you can come back and do it again if you want. Yeah. All right. Is anyone not yet clicked on this lab? Are we all here? Okay, we'll give you a couple more minutes to see some hands.
One more side note is that these instances are very cheap, right? They're Amazon throwaway instances that are probably 4 virtual cores or something, or 8 virtual cores. Those are not necessarily the fastest systems to run driverless experiments. So if you think like it's not that fast, it's probably because the system is very slow. What you really want is SSD hard drives, and you want many core CPUs, multi-core, multi-chip, multi-GPU, scale up basically, a fast single server. That's usually the best. If you have 8 GPUs on it, you can do TensorFlow, PyTorch, NLP models on steroids. If you don't have GPUs, you can still fit LightGPM, XGBoost, no problem, but anything NLP will become really slow, unless you do the statistical methods that come out of the box. But any TensorFlow CNNs and so on will be slow. Those you have to enable in the product. But once you enable them, you really want to make sure you have GPUs, otherwise you'll wait 100x longer.
All right, hello to everyone that just walked in and joined us. What we're gonna do first before we jump into an overview of recipes is we're gonna go to aquarium.h2o.ai, make an account, and once you've made an account, you're gonna click View Details on the lab that says David Driverless AI 180. Looks good. All right. After you click View Details, there's a place where you can start your lab, and that's what we'll be doing in about 20 minutes after we start with an overview and explaining recipes and all of that. So is there anyone that has not yet made an account or found this lab? Raise your hand now, or forever be lost. Okay, cool. We can go ahead and get started then. So what we're going to talk about today in the Make Your Own Agenda, or Make Your Own AI Agenda, we're going to talk about what custom recipes are, what BYOR is, and how it fits into driverless AI, and then we'll actually talk about what recipes are. We'll then together walk through a tutorial of how to use custom recipes. We also have a tutorial on how to write custom recipes, which we can talk a little bit about today, but probably won't fit into the session. And then finally, we're going to have some of our experts on stage to talk about how to write a recipe and give some examples of them. So at this point, Arno, do you want to give us our intro to recipes? If not, I can keep going. You just mentioned it.
Yeah, I think you can do it just fine.
Okay.
I'll be here for questions.
Awesome. Okay, so as you've probably heard a lot today about driverless AI, it has many key features. This is a platform for automated machine learning that can run in any major cloud or on-prem. We do automatic feature engineering. We build visualizations for exploratory data analysis. We have machine learning interpretability so that you're not building a black box, but you're actually building a model that you can really understand and explain to your business users. The types of use cases we're doing are supervised machine learning. So this is things like classification, will someone churn or not, or maybe multi-class, which group does this customer fit into? And then we also do regression and forecasting, so predicting amounts or understanding what are sales going to be in every store for every week for the next 3 months. In addition to these use cases, we can handle text data, and we can also take that final model, the Mojo, and deploy it just about anywhere. So what we're going to really be focusing on today, at this point we're sort of assuming that you've seen driverless before, you've probably used driverless before, and we're going to be focusing on the bring your own recipes. So this is the extensibility where you can add in your own feature engineering, your own models, or your own KPIs or scores into driverless AI to help shape it fit your use cases and data even better. So driverless AI is an extensible platform that works on many use cases. We were built across industries. It wasn't built for a specific type of industry or use case, and there's many different types of use cases that we're helpful with. Some of them are here. What recipes really helps with is letting you add in your domain expertise, often which might already be written in models or Python scripts, into driverless. So you can add in your custom recipes to be tested on what we're doing as well. So we have our highly tested, robust algorithms that work across industries, along with your specific business knowledge on your domain. So this is the standard workflow for driverless AI. We start by bringing in a tabular data set. This can come from basically any SQL data warehouse, maybe your data is in the cloud, and we bring in the data set. We can do exploratory data analysis using AutoViz. So this gives us the common statistical visualizations on every column and combination of columns in our data sets, so we can understand that our data is as clean as we're expecting and that there's nothing suspicious in it. The meat of driverless is this automatic model building, where we're building new features on your data with automatic feature engineering. We're testing many different algorithms, and then we're tuning those algorithms. And this is done in a genetic algorithm where over many iterations, different models compete against each other and the best ones win. Finally, once you have your final model, we have a couple things to understand that the model is robust. First, we have model documentation, which is governance that allows you to understand what data is in the model, what features were used, what worked, what didn't work, so you can really understand in the back end the technical experience that went on. We also have machine learning interpretability, so you can understand how the model makes decisions, which features are most important, which features are important for each individual person in your data, and so forth. And then all of this is done into an automatic scoring pipeline, which can deploy to Java, Python, C++, R, and this can easily fit into like a REST server, Java API, wherever you're deploying models today. So what we're going to be talking about is adding in the bring your own recipes. So this sits inside step 3, where out of the box we have 40 feature engineering, which does everything from taking out a month from a date because maybe seasonality is important, to truncated SVD, which is sort of an unsupervised clustering to understand how many different columns relate together. So now you can add in your own feature transformations. Like maybe there's a common transformation you have to do on your data on every data set you have that relates to your domain. Or maybe there's a specific algorithm that works for your use case that you want to add in that maybe we don't have. You can also add in your own score. So maybe you don't want to optimize for F1. Maybe you know exactly how much a true positive costs or a false negative and how much a false positive costs, so you can optimize for dollars instead of the generic F1. So we've been talking about them a lot, but exactly what is a recipe? Well, recipe is a part of the machine learning pipeline that helps us build models to solve a business problem. So we have sort of 4 main types of recipes we're using in driverless AI. We have transformations, which are done on the original data to create new columns. So some of this might be to clean up the data. Maybe there's a certain way you want to handle a null, or maybe there's this type you need to take a date and change the timestamp somehow. But it's making new features. We also have the ability to add in data sets. So this can be done in 2 ways. One, we have a new data recipe where you can use Python code to upload data directly into driverless AI. And we also can use data sets inside of transformations. So for example, we have an example open source recipe which can take a zip code and look up the population density, school districts, and things related to zip codes. So it brings in new data about different zip codes in the US. Another type of recipe is the algorithm that we're actually modeling. So in driverless, we have things like LightGBM or XGBoost, but maybe you have a custom loss function you want to use with those. Or maybe you just really, really like scikit-learn's extra trees and you want to use that instead. So now you can add in those models. And then again, we have the scores or KPIs so that you can optimize your problems for exactly what you want to. So in general, we call all of these BYOR, and these are bring your own recipes, so you can add in your domain expertise into driverless. Okay, but why do you care about recipes? What recipes do is they give flexibility and customization to driverless AI. We've built driverless AI to be very robust across many different use cases, but again, your domain expertise is really important in your data. So now you can add that into recipes and to driverless, and we can test your transformations on your domain knowledge along with our generic algorithms. We also have over, I think at this point, 115 recipes that we've built and we've open sourced that is on our public repo, and we'll look at that today. Many of these were curated by our Kaggle Grandmasters or Arno, so that you have the best of the best as examples for how to write yours, but also to add into your experience. So if you really want to use, say, Arima or Facebook Profit for your time series experiments, we have open sourced those and you can add them into driverless AI. All right, and then recipes are really easy to use, and we'll be talking about this today. We'll all build an experiment today where we'll add in some custom recipes and see how they're used inside of our experiment. And we do treat these as first-class citizens. So recipes you add in will be used just the way that recipes are used out of the box in driverless. So they're not treated any differently, and they'll go through the same competition that the recipes that come with driverless do. So at this point, we're going to actually get started with our tutorial. So I'm going to have, I'll be walking you through the tutorial today, but if you ever want to come back and do it again, it's going to be on our public tutorial page. And the one we'll be walking through today is Get Started with Open Source Custom Recipes. So if you want to have this tab open to follow along on your own browser today, you can. If not, I will just walk you through the experiments. All right. So we're going to jump back to Aquarium. At this point, I'm going to have everyone go to Aquarium, and we're going to click on that David's Driverless AI, if you haven't yet. View details, and we will start our lab. I'll give you just a couple minutes. If you have any problems with this, please raise your hand. We have lots of people around the room that can help you get going. And then once you hit Start Lab, there will be a link at the bottom. And this is the link that you're going to click, and it will take you to your Driverless AI instance. So we'll give just a couple minutes for everyone to get to this page, which is going to load slow for me because live demo. There we go. This will be the page you see. And we all get here, we'll get started. Pardon? Oh, yeah. Here's the link.
You can also find it from the H2OAI website under Docs and then Tutorials. The question was, can you change the font or color scheme of Driverless AI? Yes, you can. You can invert it. If you want them black and white instead of white on black or something, it actually works too. But there is not really a full palette where you can choose arbitrary skins. Not really. So you would have to, you can talk to our designers. But yes, the original design was very futuristic 2 years ago, and now we kind of live with it. I'm sure we can make a custom version of the skin. It's only a few settings where the colors are set in the font. Okay.
All right, please raise your hand if you have reached this page. I have. Awesome, and then opposite if you have not reached this page. Oh, we did it. Good job, guys. Okay, so to log in, the username and password is going to be training. I will zoom in so that's actually viewable. And I'll go ahead and sign in. All right. So in this instance, we have many preloaded data sets. Question? Can I have a friend in the front? Thank you. Okay. All right, so on this instance, we have many preloaded data sets and many pre-ran experiments, but we're going to actually load in a new data set together. So I'm going to have everyone click on the Add Dataset button, and we're going to click on File System. All right, there's lots of options when you click File System. There we go. You should see this, and then we're all going to click on Data. And it's going to load super slowly because you're all watching my screen. Okay, I'm going to, there we go, got it. We're going to click on Data, we're going to click on Splunk, and we're going to choose Churn. Once you've selected Churn, you can go ahead and click Import Selection, and that will load in the recipe, or it will load in the data set, and it will also do some summary statistics so we can understand what's in the data set. So that's Data, Splunk, Churn. All right. So the first thing, many of us probably did this earlier in the hands-on training, but we're going to really quickly look at the data set so we know what we're modeling today, because that's pretty important. So you're going to click on the Churn data set, and we're going to click on Details. All right, so I like to start with the data set rows. It's kind of readable up here. So what we're looking at here is each row is a person who is a customer of a telco. So we have information about how often they speak during the day, how often they're charged in the morning or the evening, if they do any international calling, how often they've called customer service because they had some sort of problem. And then what we're going to be predicting, the column on the very end, is churn. So some of these people have left the company and some have not. So I'm going to click back on Dataset Overview, and here we can see every column in our data set. So I'm going to search for my churn column, and here I can see that it's a little bit of an imbalanced data set. 14% of my customers have churned. So what we're going to do today is build some models to see if we can understand which customers are going to churn and which ones won't, so that in the future, as new customers come in or each month, we can see who's likely to leave us. All right, so we're going to start with no custom recipes and just run an experiment. To do that, we're going to click for Actions and go to Predict. All right, the first thing I'm going to do is click Display Name. I'm going to name my model. So this is going to be our baseline model. You can name it whatever you want, but I'm going to call it baseline because we're not going to add in any custom recipes. We're going to just let Driverless do its own thing, and then we'll add in some custom recipes and compare. Remember that Driverless is supervised machine learning, so the only thing you have to do is tell it what you want to predict. So what we want to predict is churn. And now we have many default settings that have been set for us. Is everyone at this page? Anyone need me to slow down a little bit? All right, I'm going to take that as a safe.
You'll notice we'll switch to a log loss instead of AOC out of the box because we know it's imbalanced. So it's one of the things, it's our freedom right now, but you can overwrite that with your custom score, or you can pick a different score yourself. So it's just our defaults, and those are sometimes changing from month to month without us documenting everything. So apologize if it's not always obvious what happens, but we do our best to make the models better out of the box.
Perfect. Yeah. Great question. There's two ways that we split the data in experiments. One of them is while we're building many models, because that's what an experiment does. We build hundreds of models. That's automatically going to do cross-validation. So that will we'll actually see here in the what's happening. Ooh, there we go. This is going to tell me that in my experiment, it's going to do threefold cross-validation. But I often am going to want a holdout test data set at the end that wasn't used at all in the experiment, so I can see that my model is actually robust. So for that part's not done automatically, but we can click on Datasets, and when we click on a data set, there's an option to split. And so here we can split either stratified split if it's like a binary classification, or you can do a time split if it's forecasting. Yep. So today, we're doing a kind of a small data set, and we're focusing on recipes, so I'm not going to split it, but we're going, if we were doing like a real business case, we totally would. Yep. The question was, does Driverless automatically split data? All right, so I'm naming my model baseline, and we're predicting churn. All right, and then we're going to change some of these settings down a little bit just for runtime so we can run a couple experiments today. So I'm going to drop my accuracy down to 4 and my time to 1. All right. And over on the side, we're going to see all the things that are going to happen. Everything here are models and feature engineering that comes out of the box. So we have GLM, GBM, XGBoost, and then all these are feature transformations that come with driverless. So in our second experiment we'll run is we'll add in some feature engineering and we'll see them show up here. But at this point, we'll go ahead and click Launch Experiment and have everyone start running their baseline model. So driverless gives us some nice notifications at the bottom. We see that we have a little bit of an imbalanced data set. We saw that in our data details page. So only 14% of our data churned, which is good for our telco. But we are given the option to turn on imbalanced models if we want to. So that's a nice new feature of driverless. But I'm going to close my notifications. And we can see a model. We have our first model built. And in the center here, we can see the features. So our top features are original features, how much someone's being charged, which isn't too shocking. People are leaving the telco because they don't like how much money they're spending. But it's nice that driverless is seeing that and validating our super good telco business knowledge. We can also see a little bit of engineered features here. So we're looking at customer service calls, and we're looking at the interaction between how people talk on the phone during the day and what they're getting, how they talk in the evening. So we can say several models built. Whoops.
One quick
Yes.
comment. All the numbers you ever see, the validation, performance, the numbers there are always on out-of-fold
Yes.
holdout data. So it's never on the data that it was trained on. It's always on unseen data. So we'll give you an estimate of how the model will do on new data, and we'll even give you an error bar. So in the bottom left, you always have a little error bar. That's basically the bootstrap variance or the standard deviation of the bootstrap mean. We basically do a bunch of repeated scorings on unseen data, and we'll give you the distribution of that. So it's our best effort to give you the estimate of the number. And sometimes you'll see a confusion matrix with like floating point values. It's also because it's the best estimate of the number. We don't need to necessarily use integers just because the data has integers. If that's our best estimate, we'll give you that. So all numbers are always on unseen data.
Thank you. Yep. All right. So at this point, hopefully everyone's at about 100%. No, we're not at 100%. Are we running an experiment? Oh, it's trying hard. That's almost 100. We'll round up. So we're going to now all jump to the GitHub repo where we're going to get some of the recipes we'll be using today. So I'm going to open up a new tab, and we're going to go to GitHub. And we're going to search for H2AI driverless recipes. That's kind of hard to see, isn't it? There you go. All right, before I click, raise your hand if you have clicked here and you know the link and you're all good to go. Okay, about half. I will wait. All right, let's try again. Who has made it to the Driverless AI Recipes repo? And who has not? All right, still waiting. I'll be patient. To Driverless? Do you want me to zoom somewhere? What do you need? Oh, I went to a new tab, and I went to github.com. Yeah. Good point.
In case you haven't seen the other repositories, there's H2O repository itself, right? And then there's also data table. That's the Python data table repository. So in driverless, we're using Python data table as our workhorse for our data munging. And that's a very good tool if you want to use just a pandas replacement for fast grouping, sorting, joining, file reading, file writing. It can write CSVs faster and other tools can write binary dumps. So it's really good and we use it for driverless AI. And it's totally open source. So that's H3AI data table repository. But in this case, we're looking at the recipes.
What was the question?
I was saying data table is faster than pandas because it's a recent development in C++, highly optimized. And some of these recipes that we're showing you will use data table as the basic tool, basically.
It's in Python as well.
There is an R and the Python version, and both of the main developers for either are working with Azure. Yeah.
Okay. All right. So once we've made it to the Driverless AI recipes, here on the homepage, the README is very thorough. It explains basically everything I've told you today. What are recipes? How to use them? Why do you care? But the part we like is we scroll down to the bottom and we can see the sample recipes. So actually, I'm going to have everyone scroll back up. And in case you haven't used GitHub before, one of the benefits of GitHub is you can have different repositories. So we're all running Driverless AI today 1.8.0, but there are many versions of Driverless. So there's many versions of different recipes. So what I'm going to have everyone do is click on the branch button inside of Driverless Recipes, and you'll search for 1.8.0. So whenever we use recipes, we want to make sure the recipes we're using have actually been tested inside the version of Driverless we're using. So if you're running in 1.7, you'll use 1.7 recipes, or 1.8, you'll use 1.8 recipes. I know that's hard to see, sorry. There we go.
There's also a link down in the README page to get to that specific branch, in case you don't know how to find that. But there shouldn't be too many branches.
Awesome. All right, so once we have clicked on 1.8.0, we'll see for 1.8.0 there are 107 recipes, and the latest branch is 115, so we're always adding new ones. And what we're going to add first today is a feature transformer. So we're going to scroll down to the bottom to transformers. And the feature we're going to add today, so out of the box, Driverless has a feature called interactions that will look at mathematical operations between two columns. So we actually saw that in our model. It doesn't look, there it is. We added two columns together, and that was a new feature that was important in our model. But one thing you might have noticed about this data set is we have day, evening, and night. So there are multiple columns that it might make sense to add together. And so what we're going to build today is a transformer which takes 3 or more columns and and adds them. It could also add, subtract, multiply, but well, you'd have to think about how subtract would work, but it can add or multiply. But we're going to add in a sum transformer, so we'll add 3 or more columns, and then we'll run that on our data set. So we're going to scroll down to numeric, because we are going to be augmenting our number data. So this is transformers, numeric, and then we will all choose sum. So a little bit later today, we'll probably walk through this code and talk about sort of what's happening. But at this point, all we're going to do is take this recipe and put it in Driverless. So you got to trust me that it takes 3 or more columns and adds them together. So to do that, we're going to click this button that says raw. And we're going to copy the URL at the top. All right, I can come back here for anyone that needs to. But the next step, so we're just getting this URL, and this is a way to link to recipes that are, say, in GitHub or on the web somehow. So there's 2 ways to upload recipes. One is you can give a link to wherever it's stored. The other is if it's on your local machine, you can just upload it. So if you're going to start building recipes, one of the things you might want to do is download this GitHub repository and then maybe change some of them or use them straight from your computer. But today we're going to just upload them from this link. So we'll copy this link, and then we'll go back to our Driverless AI instance. We're going to click on Experiments, and we're going to have our baseline experiment here. I'm going to click the 3 dots on the side, and I'm going to say New Model with same parameters. So if you remember, we changed the dials so that we would run really fast, so that we don't have to remember what those are. We'll just click new model with same parameters, and then we're going to get the same dials. And if we had changed any expert settings, we'd get the same expert settings too. So if you're making lots of changes for your experiments, it's a nice way to not have to remember what it all is. Yes?
So how to add this new feature to the
Yeah, we haven't done it yet. I promise we're getting there. Yeah. Yeah. To experiments? Yes. So I'm going to click on the baseline experiment. This will be named whatever you named yours. I named mine baseline. So I'm going to click new model with same parameters.
And this will use the feature brain that was saved from last time. So next time the model will already be smart and use whatever it learned from the first experiment, because in the expert settings, the feature brain level was not set to 0, but 2, which is the default. So that means if you found good features, it will retry those to start with. But obviously, if you add new transformers like our great special transformer that Michelle just added, then maybe that guy will win. We'll see.
Good. All right, so does everyone see this familiar experiment screen? It should be basically identical to what we saw earlier, except for the display name will be 1.baseline. Raise your hand if you're not here. Okay, awesome. Oh, okay. Okay. Oh. Okay. Well. Okay. If you want to just set up a new experiment, Joe, it's 418 on the settings. Okay. All right. So the first thing I'm going to do, just so I remember what I did in this, I'm going to change the display name from baseline to some transformer, because that's what we're going to add to this one. So to do that, to add recipes, so that's our question, we're going to click Expert Settings, and we have 3 options at the top. So the option we're going to use is Load Custom Recipe from URL. So we'll click this, and this is where we will paste our URL. Yes, expert settings, which is right above the scorer, expert settings. So that's expert settings. So at this time, they are Python. If you have something in like, oh, the question was, do custom recipes have to be in Python? So if you have something in like Go or R, if it's wrapped in Python, that's fine. Arno can answer that better, but basically there's Python involved.
You basically need a wheel or plain source code. And if it's scikit-learn or pandas, you don't need to do any imports or whatever. But if you have like, like something extraordinary, some Facebook Prophet or something, you have to be able to specify those dependencies. You can say, I need Facebook Prophet this version, and then we'll do a pip install for you on the platform while it's running. So you don't even have to restart or anything. You just upload that plugin. But it definitely is Pythonic. But you don't have to only use Python. You can call anything. You can make a REST call to Google's AutoML and say, you decide what I should do, right, roughly speaking. But then the production pipeline will be a little weird, because that also will make those REST calls, right? So you have to think about how far you want to go with it. If you just want to play around, you can do whatever. If you want to productionize it, then you have to be more conservative.
Awesome. All right, so let's go ahead and add in that recipe. So again, that's going to be expert settings, and then the center option, load custom recipe from URL. All right, and then I will paste in my recipe and hit save. So what you'll see currently is, it went really fast on this recipe, but there was a quick little wheel where acceptance tests were being ran. So when you add in, say, a model, when you write a model, you can say what types of problems it's for. So maybe you write a model that's only for binary classification. We will do a quick test on small data to see how it goes. So we're testing your transformers, your scores, and your models for sort of best practices, like you don't want a transformer that changes the number of rows in your data set or something like that. So those safety checks are built into Driverless, and it will give you mostly helpful error messages if something fishy goes on. Good. All right, so we all added in our custom recipe, so we'll go ahead and click Save. Awesome, and then I'm gonna zoom in, and you'll see now that sum is a list of one of the features that it's gonna try. So this is now a list of one of the features that I might try in my experiment. So one thing, Arno, I'm gonna let you talk about this one. There's a new option, expert settings for official recipes.
That's just a link to GitHub.
Oh, it doesn't, I thought it loaded
This
all
we
of
could have
them.
used to go to that website directly,
Oh,
to
got
the
it.
right branch. So that's a shortcut.
Oh, so you don't have to know what version you're in. Perfect. So we did it the hard way, but there's an easy way. The fun thing about Driverless is there's like new features all the time. So, you know, it's always getting better. Cool.
One thing quickly to show maybe on the recipes, there's a pull down where you can
Yes.
choose which transformers. And just in case you want to make sure that that sum is enabled, it will actually show up yellow there. It's one of the enabled ones. And you can disable specific ones. And in the next version, you'll also be able to specify which column gets which transformers. So sometimes you don't want age to be binned. Let's say you want it to be purely numerical, not categorical. So then you can say, do not do any binning on it, for example. So you can specify per column what transformers to allow, but not yet in this version.
Awesome. Right. So again, the location for that, so if you go in expert settings to recipes, there in transformers, models, and scores, you can turn on or off any recipe, including custom ones we just uploaded. So we just uploaded the sum transformer, so it's available on the system now. So maybe for fun, we want to try an experiment where we only use the recipe that we just built to see how it does on our model. We probably wouldn't use that with sum, but maybe for your business domain knowledge, you might want to test only your model or only your transformation. And so you could do that.
And there's the original transformer, and then there's some cat original and so on. So the ones that are for categoricals and numeric columns, you can say just use as is, don't change them. But then the model has to be able to handle categoricals natively, right? Which light GBM can do, but let's say XGBoost cannot. So we will only accept what makes sense. So we are smart enough to not let you screw up our models. But if you have your own models, then you have to have a Boolean that says, I accept the non-numeric input true or false, and by default it will say no, it has to be all numeric. But if you have a factorization machine or a FTRL or something with a hashing that takes any input, any strings, and then turns it into a vector inside, then you can say, yes, I can do non-numeric data, let's say. So there's all these configuration options. And in GitHub, as hopefully we'll see later, maybe there's some templates that show the source code of the actual custom transformer, and that's all documented. So all the fields that you can set in Python are documented. And let us know if it's not clear or if you have questions, but we did our best to document as much as we can. So this is only the very simplest example. And maybe we can look at the source code tool for that sum transformer while it's running.
Absolutely. All right, so for time today, so we can jump into some of the source code soon, we're going to go ahead and add in a scorer and a model now so we can see how that works, and then we'll run one experiment that has 3 different custom recipes we added in. So I'm going to have everyone jump back to their GitHub, and you'll probably see the raw link that you copied. You can just click back, and that will take you back here. And this time, I'm going to go back to recipes because I don't want any more transformers. We're good with our transformers. And we will go ahead and choose a scorer. So this time, instead of scrolling down the README, I'm going to actually just jump into the type of score I want. So we're going to all click Scores. And then we're doing a binary classification problem, so we don't need any regression scores, we just need classification scores. And we have this all sorted so you can kind of find what you're looking for. And then again, we want binary classification problems. So we have a couple custom recipes you can choose from. The one that we'll use together today is false discovery rate. So in a way, this is basically type 1 error or the opposite of precision, but it's basically how often we are flagging things wrong. So we'll click on false discovery rate, FDR, and that process is to click raw. So raise your hand if you haven't made it to this place in the repo. Oh, awesome, we're doing good. So we'll click raw, we'll copy the link, and we'll jump back to driverless. All right, in the expert settings, same exact step, load custom recipe from URL. We will paste our recipe. We'll run some acceptance tests that run really fast, and we'll hit save. Now, if we want to add this new score that we just added in, we're going to click the scores button, which is currently log loss, and we'll see that FDR is there. So that's our false discovery rate that we just added in. So now this model won't directly compare to the other because we're switching scoring metrics, but we can optimize for basically any business metric or KPI that you need to in your business. All right, and then the last one, was everyone able to add FDR? Roosevelt's in? All right, cool. So we'll go back to the GitHub and click the backlink. Go back to recipes, and this time we're going to choose a model. So we're all going to click on models. The type of model we're going to do today, so we have some time series models, which is going to be like ARIMA or Facebook's Profit. We have some NLP models so that you can do modeling specifically related to text. And then we have custom loss, so this is changing the loss function for things like XGBoost. But we're going to go into algorithms and just add in a completely new algorithm. And there's several that we could choose from. Maybe you really like Cat Boost, or you've seen that KNN works for your use case. But what we're going to do today is extra trees. So this comes out of scikit-learn. So it's just using scikit-learn's extra trees inside of Driverless AI. So we'll click on that one and get our raw link. So that's extra trees. So I'm going to go back to Driverless in my expert settings, click load custom recipe, and add in my extra trees. And this one will probably take a little bit longer, and we can actually see it testing. So it's seeing that extra trees works for regression. It's making sure it works for binary classification, whether or not the binary classification is a number or categories. So we're just going through and making sure that the recipe actually is going to work and not, crash in the middle of an experiment. All right, once the acceptance tests have passed, we'll click Save. And then we can again zoom into our what do these settings mean, and there's our Good Pals extra trees. So again, like Arno was saying, if we wanted, we could then go into expert settings and maybe turn off GLM or light GBM because we only want to test extra trees. Or maybe we decided, I uploaded this recipe, but I changed my mind, I actually don't want it anymore. So we can go back into the recipes and unselect it. All right, so at this point I'm going to change my display name because it's not true anymore. And I'm just going to say that this is BYOR. Because we have a custom scorer, a custom algorithm, and a custom feature engineering. And then just to be super clear, we could absolutely add more than one for each of these. Like if you wanted, you could add everything from the GitHub, but it would probably run a little bit of a long time.
Yes, you can actually provide the whole GitHub root directory, so just github.com HDI recipes / and then post that there, and then it will upload everything, which will give you a lot of choice, but it will also take maybe 20 minutes or so. Test everything.
Yep. All right. Raise your hand if you've made it to this page with all your custom recipes. Awesome. Looking good. So now we'll go ahead and click Launch Experiment. And as this runs, we'll see a couple different algorithms popping up here, including our extra trees. I don't need the notes right now. We'll probably see our sums feature engineering pop up. And then all the scores we'll see will actually be false discovery rate. So it's going to be different than our other model, which was log loss. But we'll be looking at the false discovery rate there. So while we give that a few minutes to run, oh, it's actually starting. So there's our false discovery rate so far. And currently we have an XGBoost GBM. But some of these models will be extra tree. All right. Oh, here it goes. We're tuning. At the top, it just said tuning extra trees, so it should be there soon. There's our extra tree model. So it's currently not doing as well as just XGBoost GBM. And that's sometimes the case. Maybe the recipes we add in aren't going to do as well as what's just in driverless, especially if it's maybe not domain specific, we're just trying another algorithm. But this would be a way to test out and see how it works. So it looks like we're almost at our final model, and XGBoost is still winning. But yeah, so at this point, we're going to jump back to the GitHub and talk about a little bit about how do you start writing recipes. And we'll do that a little quick because we're close on time today. But then we can take some questions too. All right. Okay, so in addition to consuming recipes, so today we all consumed recipes. We took some of the 115 that are publicly available and used them, but you might want to start writing your own. Take your business knowledge, which maybe is already written in Python, but write it so that it can run in driverless and then start testing that as well. So we sort of wanted to go over quickly the process. So the process of writing recipes, it's usually good to start with a sample data set in something like PyCharm, or maybe you really like Jupyter Notebooks, and build a recipe outside of driverless. So just test that the algorithm you want to do works. So my example, I started with my sum transformer, which takes 3 or more columns. So I just started with a pandas data frame, which had 7 columns, and then looked at how do I add those together. And that's pretty straightforward in pandas. It's dataframe.sum. But for more advanced recipes, you might have to do a little bit more debugging. We next recommend downloading the Driverless AI Recipes repository, and it has all the examples. So then you get all 115. So some of those might be similar to what you're trying to do, and you can start to understand how recipes work and see some example code there. And we also have the recipe templates, which we'll look at really quickly today. And this is basically a template for models, feature engineering, and scores. And it gives you every possible option and explains them pretty well with good comments on what they do and why you'd include it and how to write it. So probably the best place, I would say, write your code so that it works just in Python in general, and then go to a template and add it into the template. What it takes to actually write a custom recipe, the only thing you need is a text editor, so somewhere to write Python. I would recommend maybe doing something like PyCharm. So PyCharm is really nice because you can have if you download the whole driverless repository, you can have are we done with pictures? Yeah, okay, I'll show you. You can have all the recipe, oh, it's not showing you. There we go. You can have all the recipes on the side. So then this is the full Driverless AI repository. And so if I'm writing a model, I might be able to open every model and go look at how they work. So that can be really helpful. And then you can also debug in PyCharm. All right. And that's really the only thing that you need, other than a driverless AI instance to actually run it on. So bring your own recipes are for 1.7 and later. So if you have 1.6 or 1.5, recipes won't work there. But the 1.7 series and the 1.8 series, which is the latest release, is where you can actually run your recipes. To actually test your code locally, it's Python 3.6, and then data table and the driverless AI Python client. And then to write a recipe, you need to know a little bit of Python code. So that's sort of the skill set required is, yes?
Will Python 2.7 work or only 3.6 work?
Just 3.6 at this point.
Thank you.
Yeah. All right. And then one more thing is how to actually test recipes. So the easiest way to test if your recipe is working or not is to upload it to Driverless AI, where we run the acceptance tests, and it will return an error message saying why your recipe didn't work. So maybe it returned less rows than it started with, which a transformation can't do. Or there is some other issue. Maybe it was, you're writing a model which uses PyTorch and it wasn't able to install it, or something like that. The next way would be to use the Driverless AI Python and R client to sort of automate this process. So we have some example scripts on the GitHub of how to do this in Python, but basically it's a script that you can say what the data set you want to use is and the transformation location on your computer, and then it will just upload a data set, upload the transformer, turn everything off but that, and then return any error messages. So that's a nice way. You don't have to point and click and upload. You can just make changes and quickly iterate. And then if you want to test locally, we are going to extend the base class of the recipes, which is what we'll look at, and there are dummy versions so you can actually run that on your local machine without driverless. So those are the three main ways for testing. And then the last thing before we jump into showing you where the templates are is what happens if you get stuck writing custom recipes. So there's a couple things you can do. Error messages and stack traces from Driverless AI, so if you look in the logs, or if your recipe doesn't pass an acceptance test, it will give you the full stack trace there. So sometimes that helps with pinpointing what's going on. But maybe you get that full log and it doesn't mean anything to you, and you know what next. So you can take the logs, first you can look on the FAQ and the templates to see if there's similar issues to your recipe. Maybe that gives you a direction. Actually it's not coming soon anymore, I need to update that. There is a tutorial now. So today we walked through the tutorial of how to use recipes, but the second tutorial I'll point you to is to how to actually write them. And it will write the three recipes we used today, the sum transformer, FDR, and extra trees. So you can actually look at maybe there's a step we're missing. And then finally, we have a Slack community channel. So you can always join the Slack community channel, and our experts are on the channel to answer questions. So you can add logs and we can tell you what's going on there. All right.
Just one last comment. You can use data table if you're interested in learning something new, or you can use pandas or numpy. So you can do x2 pandas or x2 numpy, and then you are in old school country where everything is as expected. But if you want to learn how data table works and see how fast it is, you can just stay in data table and learn that new API. One of our Calcal Grandmasters has ported a lot of code to data table, so most of our examples will actually be in data table because that's the fastest way to handle scalable big data. So you don't want to do a two pandas too often unless you have to, because data table is multi-threaded and pandas is not.
Perfect. Right. So the last thing I want to tell you about before we jump into one more thing is inside of models or transformers or scores, there is a template file. So for example, for the model template file, this is the base class. It has a lot of commented code, and it's everything that could possibly be in a model. So every option. So there's things like we can say if our model is allowed to be regression or binary classification or multi-class, you can turn those on and off. It tells you how to actually write the fit function, the predict function. So we're not going to walk through this today for time, but I'd absolutely check out the templates. They're a really good place to start. And you can just copy the template and then just change the things you need to write your recipes. So at this point, so we've talked sort of about some basic transformers. We added some columns, but in addition, we can do custom recipes that are for very specific verticalized industries. So we're going to actually talk about some of that for a few minutes. Yes, let me get the slides for you. It's going to be just a second. Do you want to chat while I'm getting them? Okay. Yes, I got them.
So I think part of the thing is that folks have been here for a couple hours, so you learned about the basics of driverless, and then you're kind of going into what are recipes, how to use them, and so what we want to show next is sort of the art of the possible and some more advanced recipes and what can be done. So kind of give you guys a pictures like learning a little bit about driverless, learning about recipes, and how far can you go with something like this. So Ashwin.
Hey, I'm guessing you guys can hear me. She just worked it. So I'll take you through 3 different use cases that I worked on where we've used custom recipes. So One, of course, is anti-money laundering, the other one being malicious domains, and the other one is something which is called DDoS detection, is distributed denial of service attacks in the field of cybersecurity. So the first one is adds up into the area of money laundering and fraud, and the other two actually come up in the field of cybersecurity. Now, what Michelle actually showcased is one specific transformer that you guys have used to try and transform the data in a certain way so that it fits your model. What we've done is we've taken use cases where we've built extensive sets of features, like about hundreds of features that are specifically designed for specific use cases. And in this case, the first one, of course, I'm talking about is the anti-money laundering one. What we very simply tried to do is try to reduce the false positives that exist in the system. Essentially, we have like a bunch of alerts which say that they are actually money laundering. Not all of them are actually money laundering, and one of the big problems is that this is a global problem. You have about 75% to 99% of these alerts that are actually false positive, and essentially it's not a big deal to have these false positive alerts, but it does cost you. I mean, it's the manpower that's actually required for it is quite extensive. And which is why reducing it actually helps a lot. So for that, we actually build an entire module or a package which purely solves anti-money laundering. And this package has different custom transformers that are very specific to this behavior. And using that, we are able to probably come across we've actually reduced the false positive rate by about 94%. And this is essentially how you can think about using the custom recipes as well. You can have your data scientists. I mean, most of you guys here are also data scientists yourselves. So you can start building features as a part of driverless AI, which starts to add into the larger set, comprehensive set of features, which or transformers for that matter, which eventually become an entire package for a whole vertical solution if you're looking at it that way. The second example that I want, by the way, please let me know if you guys have any questions. And the second example that I wanted to talk to you about is something called as malicious domains. This essentially is a very big problem that exists globally in the field of cybersecurity. What happens is there are these really large number of dynamic domains that come up that people, that attackers tend to use as a means of trying to get you to phish, trying to basically get you, try to launch an attack on you, your organization, any of these things. These are usually vectors for like DDoS as well. And one of the things that the models need to do is try and detect that this domain that has actually come to you through your email or something that came on a website or any of these things is actually malicious. So essentially, there is literally, probably like 300 milliseconds or something of an amount of time that the system has from the time you click the link to be verified whether it's malicious or not, and then come back to you saying, okay, this link is good or this link is bad. Essentially, that's the whole process. And the model that we build looks at different aspects of the domain. It looks at the health of the domain, the longevity, when was it registered, how was it registered, what's the formation of the domain, what kind of a location is it at. It looks at many different features in this case, and then it's able to classify whether this domain is good or bad. And that essentially helps feed the model when you in your organization are going ahead and clicking a simple link. So the simple process of clicking a link in a web page, early morning, you're having a coffee and trying to see what's on news, that essentially goes through some of these models. And this model, of course, if you see, we really do get pretty good performance in most of these custom models, and most of these are using driverless AI to build a model and deploy them. Finally, the third one that I wanted to talk to you about as a part of the whole the custom solution development was something called as DDoS detection. DDoS is, for people who don't necessarily know, is distributed denial of service attacks, where a large number of resources around the world, usually botnets, are marshaled to actually attack your system, attack an organizational resource, or any of these things. It could be pure revenge. It could be, for monetary purposes. It could be basically to side channel another attack. A lot of organizations face DDoS attacks when they're actually being hacked by another channel. So this is a very common mechanism or a vector, when things are being done. So which is why the model that we've built actually actually tries and identifies early warnings, for any kind of DDoS that is happening around the world. And this model too does a fantastic, phenomenal job. But the thing about this is all of these three use cases that I was talking about, or these three solutions that I was talking about, have a specific set of features that we engineer that form a package for each of these solutions. And these packages contain very specific transformers, many of them that were actually many more than the one that was showcased to you. They also contain custom scorers, probably sometimes custom models as well, that solve specific purposes. So you can look at these three as like examples of applied about how you could use recipes to eventually build a model and then apply it to problems at space wherever you guys work at. Having said that, if you guys have any questions, please let me know. If not, yes, please.
So what amount of retraining did you have to do to get to a 90% accuracy?
And could you let me know which one you're specifically asking, or is it just any one of them?
All the three of them, to be honest. All of them are in the 90s. The accuracy of the model. Generally, most data scientists settle for about between 75 and 80%. So
that's actually
what was the incremental effort involved is where I'm going with the whole thing.
So that's actually a fantastic question, and I'll tease out something else out of that. One of the things is that I specialize in the field of like anomalous behavior and malicious behavior. So when I go through the process, these things kind of come easy to me, not because that's what I do, but it's just so it's not as much retraining and training that I went through, probably a couple of models and so on. What I wanted to draw out of that is if you have subject matter experts in your organization, the subject matter experts could work along with your data scientists, or your data scientists themselves could be subject matter experts who could build the model, with much less effort. In addition to that, you have driverless AI itself, which gives you the best probable model or the best possible model in the whole design of the pipeline. So that kind of helps the process. I'm guessing that answers your question. Yeah.
In the DDoS, the false positives you had in the fraud detection or the money laundering, can you interchangeably apply, because there are false positives in DDoS also, because there are favorable events which are happening, which looks like DDoS, but it's not.
Yeah.
So you can apply the same false positive algorithm.
Oh, you're saying the detection of false positives in DDoS?
Yeah.
You can. So you can actually do that, and that's one of the fundamental things that we try to stick on to try and identify good behavior versus bad behavior. I mean, if you look at it, the fundamental essence of how DDoS happens is the whole timing is very narrow when there's an attack happening, and when there is no attack, there is a huge window, where there's nothing happening. So we use a lot of features specifically as time, a function of time. I wouldn't want to say time series itself, like a function of time, which tends to give us more value. What is the actual behavior, what is not?
False positive in DDoS, and I'm pretty deep in DDoS, that's why I kind of know that. Isn't really about DDoS isn't always an attack. It's
True.
An event.
Yeah.
Some news occurs and then your website gets hit.
So yeah.
That's what I meant.
So okay, you're talking about /dot effect.
Yeah.
Okay. Yeah. So you can use the same model for the /dot effect as well. It just depends on what you define is the problem, and you can use the same model is what I'm saying. Yeah. That's about it. Great. Thank you guys. Thanks.
All right. Thanks everyone for coming to this session. If you have any questions, you can always come and ask us. And I think there's another session in this room. Okay, so we'll let that happen now. Thanks.